Hello and welcome to this last video for the topic on quadratics, where we're going to be studying how we can analyze the number of solutions in a quadratic equation. Let's consider an equation, in general, any quadratic equation that looks like this. Yeah, and we're going to set this equal to 0. So we're going to omit this part here, and we're going to set this equal to 0. How can we solve this? Well, we know that we have three different methods. We have been talking about these three methods for a while. The methods are factorizing, completing the square, and the general formula. The thing about factorizing is that factorizing will never tell us if that method goes wrong until we find out that we cannot solve it. It's like, okay, I'm struggling with finding the value, so, well, I can try something different, but it's not going to be the best method to understand what happens when I have no real solutions. Completing the square will eventually tell us that we have no real solutions if you end up with a negative root. As you will see, I'm going to go over this now with the general formula. Remember the formula that we call the general formula that looks like this. X is equal to negative b plus or minus b squared minus 4ac, everything divided over 2a. This formula has here, inside of the square root, a very important element that we're going to be calling the discriminant. The discriminant that we usually write with the letter capital delta is the value for b squared minus 4ac, and is the one responsible for telling us how many solutions does this equation have. You know that a quadratic equation can have up to 2 solutions, but could have only one, or could have 0 solutions. Imagine, for example, that I have my x-axis over here. Well, that's horrible axis. Let me use this. I have my x-axis over here, and then my parabola is going to do this, crossing the axis twice. 2 solutions, 2 different real solutions. Yeah, 2 different real solutions. This means that my discriminant is greater than 0. When my discriminant is greater than 0, this plus or minus will be adding and subtracting a value. So we're going to end up with 2 different solutions. So this is scenario where we have 2 real roots with the discriminant being greater than 0. What's a different scenario? A different scenario is what happens if, for example, I have my x-axis around here. I don't know why you're not there. I have my x-axis over here, and then my parabola comes all the way down here. It's going to cross, and it's going to go up again. This is what we usually call a repeated root, or a double root. We usually use here in Uruguay. The repeated root or the double root is only one real solution. This is the case when my delta is exactly equal to 0. What happens when my delta is exactly equal to 0? Well, this term, either if you add it or subtract it, is going to give you the same result, and the value for x is going to be negative b over 2a. If you go back to when we study maximums and minimums, you should know that negative b over 2a is the vertex. So here the vertex and the root coincide. And then finally, there's scenario number 3. Scenario number 3 is the scenario when the parabola is not going to meet with the x-axis. It's going to be doing something like this. In this case, that there are no real solutions. This is the case when my discriminant is negative, because when my discriminant is negative, the square root of a negative is not a real number. It's going to be studied In the following paper, this is part of Pure Mathematics 3, complex numbers. So for now, we don't need to focus around this. We just need to focus on the fact that having a discriminant that is negative implies having no real solutions. So how can we put this in practice? So we're going to look at two different exercises. One exercise that has to do alone with number of roots, and then one that has to do with intersections. So we're going to begin with this first example. This is going to be my example number 1. We're going to be considering this equation, 4x squared plus 4k, sorry, plus kx plus 1 equal to 0. And we want to find the value for k such that the equation has one repeated root. This is my first example. We want to find the value for k so that this equation has one repeated root. Just to think about it, this means that the equations and the solutions and the number of solutions for this equation will change as k take different values. This value of k is called a parameter, and if my k is 1, we will have certain solutions. If my k is 2, we will have certain solutions. If my k is negative pi over 2, we will have different solutions. So the idea is, which is the value I need to plug in here so that this equation has one repeated root. And now, the only thing we need to remember is that one repeated root means that my discriminant delta has to be equal to 0. In order to guarantee that my discriminant, that my equation has one repeated root, we need to guarantee that my discriminant is equal to 0. So what is my discriminant? My discriminant is b squared minus 4 times a times c. But who are A, B, and C? A, B, and C are, if we recall, the constants that are with each term, that are in each term, the coefficients. So in this case, we can see that my A is going to be 4, my B is going to be K, and my C is going to be 1. So I need to plug that here and solve. B squared is k squared minus 4 times a, that is 4, is 4 times c, that is 1 equal to 0. K squared minus 4 times 4 is 16. 16 times 1 is 1. 16 equals to 0. And therefore k squared is equal to 16. Thus, I'm getting two different solutions. K is 4 and k is negative 4. And this is the end of this particular task because we only wanted the values for k so that it has one repeated root. The idea is if I plug in here 4 or if I plug in here negative 4, this equation will only have one solution. Okay, it's quite straightforward, I believe. Then another question could be, well, which are the solutions? Well, then you just go and solve using any method you like, using the value for k that you found. But in essence, it's quite straightforward. Let's take a look at a different exercise now, because now we're going to see simultaneous equations. We're going to have a line that is y equals kx minus 1. And y equals to x squared minus 2x. And we want to find, again, the value for k, such that the line and the curve intersect at two different points. So again, what does to intersect at two different points mean? This means that my discriminant is positive, because in order to have, as we were mentioning earlier, in order to have an intersection with two different points, we would mean that my discriminant is positive. But which discriminant? Because remember that my discriminant is b squared minus 4 times a times c, but I don't have this just yet. I need to build it. How am I going to build it? Well, we have y is equal to kx minus 1, and y is equal to x squared minus 2x. So what I'm going to do now is I'm going to set that this that I'm actually solving is a pair of simultaneous equations. And this value for y must be this very same value for y. So if these two are equal, then these two are also equal. So from here, I can say, well, kx minus 1 has to be equal to x squared minus 2x. I'm going to start accommodating everything. I'm going to have negative x squared. Then I'm going to have k plus 2x and minus 1 equal to 0. It doesn't matter if you do it to the left or to the right, you would end up with the same equation at the end. But the thing is that now I have my values for a, that is negative 1, b, that is k plus 2, and c, that is negative 1. So I just plug this in here. B is k plus 2, so going to be k plus 2 squared minus 4 times negative 1 times negative 1 greater than 0. So let's start working this out. This is going to be k squared plus 4k plus 4, and this is negative 4 times negative 1. This is 4 times negative 1. This is negative 4. I wrote a k here. This should be a 4. And then minus 4 greater than 0. So this becomes k squared plus 4k greater than 0. So what we need to find essentially is which are the values of k such that this expression is positive. How do we do it? Well, how do we do this? We did this in a previous video. We worked with a previous video how to solve inequalities, and we say that one method was studying the sign. The sign of k squared plus k in an excess of k. We know that this has two roots. These roots, I believe that you can find them. There are 0 and negative 4. In case you don't know what I'm talking about, you can check my previous videos where I studied the roots for this equation. And then as this term here is positive, I can write positive, positive like this. And then I can say that my solution is here and here. So what is it that I'm looking for? I'm looking for values for k that are either greater than 0 or values of k that are less than negative 4. These are the set of values that will make this system of equations, this line and this curve, to intersect at two different points. This is a very interesting, it's a very complete exercise. In case you want to look at it again, it's uploaded to my webpage, as well as there are other videos as well. So as usual, thank you for watching. If you have any comments or any suggestions, please leave them in the comment section below, and hope to see you for our next topic. Thank you for watching.